class in problem solving, mathematical investigation, and modeling. For today, we will talk about the 4 principles of problem solving by George Polya, also known as Polya's problem solving techniques. First, we start with some background about George Polya. George Polya was a Hungarian mathematician. George Polya was born on December 13, 1887. Again, George Polya was born on December 13, 1887 in Budapest, Hungary. That means that George Polya was originally a Hungarian citizen. After completing his law study and study of languages and literacy, George Polya completed his doctorate program in mathematics. From 1914 to 1928, George Polya taught at the Swiss Federal Institute of Technology in Zurich, Switzerland, where he became a Swiss citizen. And in 1924, George Polya became the first international Rockefeller Fellow, and he spent 1 year in Great Britain. Again, George Polya taught at the Swiss Federal Institute of Technology in Zurich, Switzerland, where he became a Swiss citizen, and he taught there from 1914 to 1928. And in 1924, George Polya became the first international Rockefeller Fellow, where he spent 1 year in Great Britain. And again, in 1933, George Polya became an international Rockefeller Fellow, where he spent some time at the Princeton University. In 1940, George Polya immigrated to the United States and became an American citizen. And in the United States, he taught from 1952 to 1954 at Stanford University. George, George Polya retired in 1954 but continued to teach until 1978. And in 1976, George Polya was elected member of the National Academy of Sciences in the United States with the office and building located in Washington, District of Columbia, or Washington, D.C. The National Academy of Sciences, NAS, is an NGO. It is a non-profit organization. It is a non-governmental organization. And members of the National Academy of Sciences were elected on the basis of their distinguished contributions to the sciences and because of their original researches. And George Polya was elected member of the National Academy of Sciences in 1976. The members of the National Academy of Sciences serve as advisors to the United States pro bono, that means for free, on matters pertaining to science and technology. The National Academy of Sciences was founded on March 3, 1963 by Alexander Dallas Bush and Abraham Lincoln. Again, the National Academy of Sciences was founded on March 3, 1863. That's almost more than 150 years. That's for sure more than 150 years. And it was founded by Alexander Dallas Bush and Abraham Lincoln. Now, the works of George Polya were compiled in 4 volumes. The first 2 volumes are dedicated to his contributions in complex analysis. The third volume is dedicated to other branches of analysis, including mathematical physics. And the fourth and last volume of the works of George Polya is dedicated to his contributions to probability theory, number theory, combinatorics, and teaching and learning in mathematics. Now, George Polya's techniques for problem solving are summarized into 4 principles known as Polya's principles of problem solving. Polya's principles of problem solving, or Polya's techniques for problem solving, appeared in his book entitled How to Solve It. The book by George Polya called How to Solve It was published in 1945, and this book became his most prized publication. And this book was translated into 17 languages. George Polya died in Palo Alto, California on September 7, 1985. We now state the four principles of problem solving by George Polya. The four principles of problem solving by George Polya are as follows. Polya's first principle of problem solving is understand the problem. Polya's second principle of problem solving is devise a plan. And Polya's third principle of problem solving is carry out the plan. And the last of Polya's four principles of problem solving is look back. We start with understand the problem. The reason why many students are not able to solve a problem is because they do not understand the problem fully or even a part of the problem. Now, Polya had suggested strategies to help students understand the problem. And these suggestions were made for the teachers to help the students understand the problem. According to Polya, students may be asked questions to help them understand the problem. And some of these questions are the following. Number one, the teacher may ask the students if they understand all the words used in the problem, because it will be most difficult for the students to understand the problem in its entirety if there is a word or words that they do not understand the meaning and how these words are used in the problem. And it is important that when a teacher uses a word, a mathematical term in the problem, the teacher has to ensure that the term has been explained to the students before and the students have obtained or attained a certain level of understanding of the meaning of the terms or mathematical terms used in the problem. And number two, the students, according to Polya, may be asked to state again the problem in their own words using their own words, because allowing students to state the problems the way they understand the problem and using their own words, the teacher will be able to determine if they have the correct understanding of the problem. And number 3, the students may be asked if they can imagine a picture or draw a diagram to as a representation of the problem. Because in many mathematics problem, understanding is facilitated by a picture or diagram or a graph. It's easier for many students to visualize, understand the problem, and determine what is being asked in the problem if they can see it in picture, in graph, or in diagram. And number 4, the students may be asked about the unknown. What is the unknown in the problem? What are the data given in the problem? And what are the conditions, or what is the condition given in the problem? Now, with regards to condition that must be satisfied, the condition that is given in the problem and that must be satisfied by the solution of the problem, the students have to ask if the data, the condition are sufficient or insufficient. They have to determine if the condition is redundant or the conditions are contradictory. And the second principle of Polya's for problem solving is devise a plan. Polya's second principle of problem solving is devise a plan. In this second principle, the student will now think of a way of how to solve the problem. And according to George Polya, there is more than one way of solving a problem. That is, there are reasonable ways in solving most or all of the problems. But the student should be able to solve a problem using some strategy. A strategy that will enable the student to solve the problem more efficiently. And the skill in choosing the strategy that is most appropriate for solving the given problem is developed when you actually solve many problems. In solving many problems, you will find it increasingly easier to choose the strategy that is best and most appropriate to solve the problem and to solve it most efficiently. And Polya suggested, made a partial list of strategies that may be used in devising a plan to solve a problem. Some of these strategies are guess and check. That is, you initially guess, you initially make a guess about the solution of the problem, and you check if your guess will work out. Number 2, make an orderly list. This is a list of possible solutions to the problem, and from your list you eliminate some of the possibilities. So number 3 is eliminate possibilities. The most remote possible solution is eliminated from your list. And number 4 is consider special cases. There are cases in which the solution will not work, and this may be involved in the problem. So one of the strategies is to consider special cases. And next is the use of symmetry. If this solution works for this part of the problem, the same solution may work for the other part of the problem. And next strategy is use of direct reasoning. And another strategy is solve an equation. And another is solve a simpler problem. Other strategies that George Polya suggested include looking for a pattern, using a formula, using a mathematical model, drawing a diagram or a picture or a graph, working backwards. In working backwards, you start with an answer and then you work backwards in the problem to check if the conditions given in the problem are satisfied by the solution you have. And another is use of formula, and of course B. George Polya just suggested that problem solvers should be ingenious, which means that you have to be creative, inventive, and innovative. You may discover your own approach, a more efficient approach to solving a problem. Now let me write this partial list of strategies suggested by George Polya. Again, these are the partial list of strategies that students may use in devising a plan or approaching to solve a problem. But George Polya said that the choice, the skill in choosing which among these strategies is best to use and most appropriate for solving a problem is developed when you actually solve many problems. So I suggest that you solve many problems, and you will find, as George Polya said, that it becomes increasingly easier for you to select the strategy that is most efficient, most effective, and the most appropriate for solving a problem. Some of these strategies are the following: guess and check, make an orderly list, eliminate possibilities beginning with the most remote possible solution, use symmetry, use a formula, use a model, consider special cases, use direct reasoning, work backwards. You start with an answer or a solution, and you work backwards to check if the conditions given in the problem are satisfied. Be ingenious, be creative, inventive, and innovative. Be resourceful. 11. Look for a pattern. Draw a diagram, a graph, or a picture. 13. Solve an equation. 14. Solve a simpler problem. In some cases, you will find that you cannot solve a problem immediately or directly, and in that case you have to consider simpler problem or auxiliary problem or some related problems related to the given problem, and use the results of these simpler problems or related problems or auxiliary problems to solve the given problems. Also, in devising a plan according to Polya, the students have to go back to the definitions, because you will find the definitions of some mathematical terms useful in arriving at a plan on how to approach and solve the problem. And the students may also ask themselves if some theorems may be useful to solve the problem, because in some problems you are not always asked to look for a missing value, for the unknown value, but you are asked to show or to prove a statement, a mathematical statement or a logical statement. And that is the suggestions of George Polya. The second principle of problem solving by Polya is devise a plan. The third principle of problem solving by George Polya is carry out the plan. Once you have finally decided on which plan, approach, and strategy to employ to solve the given problem, the next step is to carry out the plan. In deciding the best plan or strategy to employ in solving the problem, the problem solver or the students or you have to determine the connections between the data given, information given, and the unknown, or the relationship between the data and the unknown. And carrying out the plan is definitely easier than deciding and devising a plan to use. And in carrying out your plan, you have to check each step of the plan, see if you are carrying each step of the plan correctly, and see if you can prove that each step is correct. And George Polya advised that problem solvers should be patient and should exercise care in carrying out their plan of solution to the problem. And if ever the plan does not work, George Polya said that there is no need to worry. You can simply discard the plan and devise another one and try to carry it out and see if the new plan will work out. And that is exactly how mathematicians and even professionals solve and approach the problems. And the last principle of problem solving by George Polya is look back. And this principle is based on the idea of reflection. Once you have obtained the solution, you reflect on the processes that you undergo at arriving at the solution. And the solution should be made to reflect, to do the reflection, reflect on the steps they have taken and the process they undergo towards arriving at the solution of a problem, and see which strategy works and which strategy does not work. And because it is through reflection that the student will be able to know or determine if the plan that they have decided to use or they have carried out is efficient and effective and may be used to solve problems that are similar to the problems that they have just solved. Now we take an example of a problem to illustrate how these four principles of problem solving by George Polya work. We now solve a problem to illustrate how we can apply George Polya's four principles of problem solving. Consider the following problem. Nina is 39 years old now. Natalie is twice as old as Nina 5 years ago. The question is, how old is Natalie now? Now there are two elements of time involved in this problem. The first is the present time, and the second is the time 5 years ago. The age of Nina, the first principle of George Polya, by the way, in problem solving is understand the problem. Now we will try to understand the problem by analyzing the problem. And as I said, there are two elements of time elements involved in the problem, as indicated by the word now, because so the now represents the present time, and these words 5 years ago represents a time in the past, a time 5 years ago. And the students have to understand that the words now is the present time and 5 years ago represents a time in the past. Now, in understanding the problem, the students have to be able to identify the given information. At the present time, the age of Nina is 39 years old. And we write it down. part of understanding what is being asked in the problem is identifying the information given that may be used to solve the problem or the question in the problem. And we write from the first sentence given, age of Nina now at present is 39 years. Nina is 39 years old now at present time. Natalie is twice. Now, the student has to understand that twice represent 2 times another quantity. Now, if the student does not understand the word twice or has misinterpreted the word twice, then that student will not be able to solve the problem or will arrive at an incorrect solution to the problem because the student does not understand the word twice, that it means 2 times 2 multiplied by another quantity. And the teacher should ask the students if they understand all the words used in the problem. So here it represents 2 times another quantity, and in this problem, that quantity is the age of Nina 5 years ago. This means that 5 years ago, the age of Natalie is twice the age of 2 times the age of Nina 5 years ago. The question is, how old is Natalie now? The age of Nina now is given 39 years old, but the problem asked or the unknown is the age of Natalie now. In one of the strategies in devising a plan is solving an equation. And if you select the strategy of solving an equation, there should be an unknown represented by a variable to represent the unknown so that you can write the equation in terms of this unknown and solve the equation for the value of this unknown. And since the age of Natalie now is unknown, we take any variable to represent the age of Natalie now at present time. And I will use the variable x to represent the age of Natalie now. Now, the second principle of problem solving by George Polya is devising a plan. I have already mentioned that the best way to solve this problem is to solve an equation for which we needed a variable to represent the unknown. And we have actually used the variable x to represent the age of Natalie now. And using this variable x, the unknown variable x to represent the age of Natalie now, we will write the equation from which we can solve x. Now again, how do you know which strategy to use? You will know which strategy to use if you have solved many problems before. Because in solving many problems, you will know upon seeing a given problem that the problem is similar to one of the problems you have solved before. And for the problems that you have solved before, and you can apply or use the same approach for solving now the given problem. Now, to write the equation using the variable x, we go back to the second sentence in the problem given. Natalie is twice as old as Nina 5 years ago. Now, to get the age of Nina 5 years ago and the age of Natalie 5 years ago, we have to go back. We have to count 5 years backwards, and that means subtracting, going 5 years back is subtracting 5 years from the age of Natalie now, and subtracting 5 years from the age of Nina now, 39, subtracting 5 years from the age of Nina now, we will get or obtain the age of Nina 5 years ago. Subtracting from the age of Nina now, subtracting 5 years from the age of Nina now, which is 39, we get 39 minus 5 is 34. So the age of Nina 5 years ago is 34, or Nina was 34 years old 5 years ago. Now we also get the age of Natalie 5 years ago. Natalie is X years old now. We do not know exactly the age of Natalie now at present time or today, so we represent it by the variable X. And we have to go 5 years back to get the age of Natalie 5 years ago, or that's simply subtracting 5 from the age of Natalie now, which is X. So X minus 5 is the age of Natalie 5 years ago. Now, we have the ages of Nina and Natalie 5 years ago. We now write the equation involving the unknown variable X using this second sentence that says Natalie is twice as old as 5 years ago. This also means that we write the equation in terms of the ages of Nina and Natalie 5 years ago. We do not write the equation. The students should also be able to decide between using their ages now at present time and their ages 5 years ago. But on analysis of the second sentence given in the problem, you will know that the equation should be written using the ages of Nina and Natalie 5 years ago, because the second sentence says that Natalie is twice as old as Nina 5 years ago. Now we write that sentence in mathematical sentence, in terms of mathematical sentence, in terms of the variable X. The age of Natalie 5 years ago is X minus 5. And Natalie is twice. The age of Natalie is, the age of Natalie 5 years ago is twice the age of Nina 5 years ago. This is now the equation from which we can solve the age of Natalie at present time, or the age of Natalie now. 5 years ago, the second sentence says 5 years ago, 2 times the age of Natalie. Natalie is equal to the age of Nina, or Natalie is twice as old as Nina 5 years ago. Natalie is twice as old as Nina 5 years ago. And from this equation, this is now our plan. This is now our strategy to solve the problem using an equation or solving an equation to solve the problem. Now we carry out the plan. We go and proceed by solving this equation step by step, and George Polya suggested that we take care and patience in carrying out our plan. And in solving an equation, we apply properties of equality. And in solving an equation, we said that, or we know that only the unknown variable should be left at one side of the equation, and all the constant terms should be at the other side of the equation. So we start eliminating the constants minus 5 and 2, beginning with 2, by dividing both sides of the equation by 2. And that's the division property of equality that says dividing both sides of an equation by non-zero constant retains the equality. So we divide both sides of the equation by 2. And dividing both sides by 2, dividing the left side by 2, 2 and 2 will cancel out because it's 1. And we are left with x minus 5 at the left hand side. And dividing the right hand side by 2, we get 34 divided by 2 is 17. And finally, we eliminate minus 5 from the left. By using addition property of equality, we add 5 to both sides of the equation, or others would simply say transpose minus 5 to the right hand side. And when you transpose a term from one side of the equation to other side of the equation, we take the opposite sign of the term. We do that transposition. If we transpose minus 5 to the right, it becomes plus 5. And we are left with x at the left hand side. And finally, we perform addition at the right hand side. 17 plus 5 is 22. We have carried out our plan and we obtained a solution. X equals 22, which means that the age of Natalie now is 22 years. Natalie is 22 years old now. And the fourth and last principle of problem solving of George Polya is look back. For this particular problem, a way to look back is to check if the solution obtained or the value of x obtained is correct by substituting that into the equation that we have. 2 times quantity x minus 5 equals 34. Now, substituting the value of x in our equation, 2 times x minus 5, we want to check if for x equals 22, the equation will be true. So we initially write a question mark above the equality sign. X is 22, we have 2 times quantity 22 minus 5 equals 34. With the question mark, 22 minus 5 is 17. And we multiply 17 by 2 and we check if it's equal to 34. And 2 times 17 is 34. And it's equal to the value at the right hand side of the equation. So this fourth principle of problem solving by George Polya, in which we check our solution, tells us that the solution we obtained or the value of x we obtained is correct. And it tells us that twice the age of Natalie 5 years ago is equal to the age of Nina 5 years ago. And that completes our lesson for today on George Polya's four principles of problem solving. If you have questions about the lesson today, you ask your questions in the comments below. And thank you for joining me in my class today in problem solving, mathematical investigation, and modeling.